Good afternoon and welcome to this webinar on Lifeline Infrastructure Systems. Today we have a panel of experts discussing the hazard resilience of the energy sector systems. I should mention at the onset that the webinar is being recorded. My name is Craig Davis. I am retired from the Los Angeles Department of Water and Power after over 30 years of service and now working on my own. I am on I'm the co-chair of the conference, being jointly organized by the American Society of Civil Engineers Infrastructure Resilience Division and UCLA Engineering. This conference, Lifelines 2021-22, which commemorates the 50-year anniversary of the 1971 San Fernando earthquake, was launched on February 9th, 2021 during our webinar on this topic. We have events planned throughout the 2021 calendar year related to the conference theme of understanding, improving, and operationalizing hazard resilience in lifeline systems, culminating with the in-person conference on the UCLA campus in February of 2022. We encourage you to visit the Lifelines 2021 website, where you will be able to access the video of this and prior events, the itinerary of future events, and the conference book of abstracts, among other resources. We are delighted that you have joined us for this webinar. We have an outstanding program for you that explores resilience in the energy sector lifeline systems. The main theme for discussion will cover lessons learned and implemented since the 1971 earthquake and the plans and policies to make the energy sector lifeline systems more resilient to hazards and future events. We will initiate the program with a short keynote presentation followed by a moderated question and answer session in our panel of experts. Or with our panel of experts, I'm sorry. My co-moderator, Fred Grant, will introduce the panel after the presentation. Before proceeding with our keynote presentation, let me take a moment to thank all of our Lifelines 2021-22 sponsors, and especially the organizations who are participating in this session for contributing to the and supporting the conference. Now we will transition to our main program. We will welcome questions for the speaker and the panel members. Please enter them at any time using the QA button at the bottom of your screen. Now it is my great pleasure to introduce to you our keynote speaker, Professor and Associate Dean Rachel Davidson from the University of Delaware. After her talk, Professor Davidson will join the panel and questions for her will be addressed in that part of the forum.
Thank you, Craig. Well, I'm delighted to be here today. As you all know, we're here as part of this ongoing commemoration of the San Fernando earthquake, which occurred in 1971, 50 years ago. So next slide, please. So as most of you know, this was a seminal event in the development of lifeline earthquake engineering and earthquake engineering more generally. So more specifically today, we're going to talk about the energy sector. The energy sector is a very large economy, includes multiple diverse forms of renewable and non-renewable sources. Next slide. So it's a broad sector we're talking about. And my job today is to set the stage for an exciting and productive discussion about energy sector resilience. And with the San Fernando earthquake in mind, we want to look back at what's happened over the last 50 years and use that as a springboard to look at the next 50 years and where we think we're heading and what we can do to maximize our efforts towards resilience. So next slide, please. I thought I'd start by just reminding everyone how long ago 1971 was. Of course, some of the styles have come back, but they were quite different at the time. 1971, a gallon of gas was just 40 cents. It was the year Amtrak was created. Jim Morrison died. The Partridge Family was on television. And there were some key inventions. But more directly relevant, so if you've got your mindset into 1971, if we look more directly at the energy sector, next slide, please. We can look at what's changed in the last 50 years. So in terms of production, the production has gone up by 53%, mostly due to the growth of natural gas, renewables, and nuclear energy. The consumption If you can click forward, please. So in terms of consumption has gone up about 34% and across most sectors. But if we look at that on a per capita basis, it's actually gone down a little bit. Next click. Per capita consumption has stayed about level, gone down just a little bit. So if we look at, those are pretty big changes though in the course of the last 50 years. So next slide, please. I thought what I'd do is just kind of summarize the very broad area that's grown out of that event and what we've learned about energy sector resilience to earthquakes and to other hazards. So there are a lot of areas that have been explored, starting with the hazards themselves. So a lot of work on understanding ground shaking and other collateral hazards like liquefaction, which can be so important for the energy sector, landslides, and more recently, multiple hazards. In California, for example, understanding how to address wildfire and earthquakes together. Next. So even understanding where the hazards exist, of course, then there was clearly a need to understand the likelihood of different components of these energy systems being damaged. There's been a lot of research on that area and work developing new ways to minimize damage using finite element analysis, experimental research, empirical work. But of course, people realize that part of what makes lifelines its own challenge is that we can't look at each component individually. Next, we have to also look at the layout of the network. We have to treat these as systems as a whole. And that offers a key to some opportunities for resilience by adding redundancy to networks, for example. So that's been a big area of study as well. Next. We've also, in the last 20 years, there's been a lot of interest in how the energy-related lines interact and are interdependent with other kinds of lifelines. And of course, electricity sits at the center of a lot of those interdependencies. So understanding how interruptions in one of these lifelines can affect a lot of the others, even if they're not directly damaged. Next, there's been a lot of work thinking about the time period beyond when an earthquake actually happens. So when there's damage or impact on a system, what's the process by which it gets restored? Because of course, part of what people care about is not just when they lose service, but how long it's going to last. So there's been a lot of work trying to understand that restoration period, which is of course where there's a lot of interactions between the physical built environment and the humans that operate and use it. Next, in the last 10 or 20 years, also there's been a large focus on resilience, which puts even more emphasis on this period after an event, and acknowledging that we're likely to have some kind of damage, some kind of impact from earthquakes or other events, and we should also be thinking about how people adapt to and cope with and respond to the event. So after the shaking stops, for example. Next, along those lines, there's currently a lot of interest in focusing on the societal impacts of earthquakes and other events. So we recognize that the reason energy sector lifelines and other lifelines are so critical is because they're critical for the way communities thrive. So we're trying to understand how interruptions in the system service actually translate into interruptions in our healthcare or business operations or other activities. We also recognize that people are very adaptive, operators and consumers. Next, please. And communities adapt to interruptions in clever and important ways. And we should understand how those different adaptations, either delaying or reducing demand or supplementing supply in different ways, can help them meet their needs and meet those societal uses, even perhaps before some of the damage has been repaired. And finally, next, all of this study is happening in the context that's changed a lot in the last 50 years. So, as electric cars become more and more prevalent, the energy demand patterns are changing. Climate change, of course, is happening and is an important context for all of this work. And this year, we know now that understanding a pandemic and other kind of hazards that might be co-occurring can be important as well. So next slide. So this is a very broad area. There's been a lot that's been that we've learned, and there's also a lot that's been done and implemented in practice. I'm going to let my colleagues on the panel talk more about this from their points of view as practitioners in some of the energy sector companies, but they span the range of a lot of efforts to reduce impact pre-event by changing the design of different components, retrofitting existing components or modifying networks, also planning the restoration process for after an event, planning adaptations, providing better information to consumers and so forth. So with that kind of broad picture of what's been done and what we've learned over the last 50 years, when we think about the next 50 years and how we can continue to make progress, one way of doing it is to think about the opportunities and also the barriers. So next slide, please. We can think about what have been the barriers to progress in the past, and what do you think the barriers might be now and to making more progress in the future, and how can we overcome them? So these are just some kinds of ideas. One is that we've got a lot of facilities and equipment that already exist. You can't just erase those and start with a clean slate. Resource limitations are often described as a barrier, not having enough financial resources or human resources. Sometimes if there's no champion to push things forward, is one of the barriers that we still are lacking some important technical knowledge. Is there something we don't understand about the hazards or about the component behavior or the translation to societal impact? What is it that we need to know to be able to move forward? There's often a barrier to progress is competing priorities. So maybe it's resilience or reducing risk in this way has to compete sometimes with other priorities a company or a community might have. There can be psychological barriers, concern about avoiding uncertainty or a lack of urgency. And then there's also a lot of contextual issues that can come into play. Maybe the mismatch between the distribution of who's paying for improved resilience and who's reaping the benefits, or a lack of collaboration across organizations that have to collaborate and so forth. So this is just one thing we can think about as we think about our efforts to continue to improve resilience in the future. So with that, next slide, please. I'll just pose a couple questions which we could potentially take up with the panel, is to think about the next 50 years now. What are the most important goals? Where do we need to continue moving forward? How can we what are the most promising ways to try to achieve those goals? And what are the barriers we think we might face so that we can think about how to overcome them? Thank you very much.
Thank you, Professor Davidson. That was very good, and we appreciate the posed questions. We will attempt to address those. Now we'll be transitioning to the panel portion of the program, and we will address those questions under that forum as mentioned earlier. We welcome from the audience your further questions for the speaker and the experts. Please enter them at any time using the QA button accessible at the bottom of your screen. I will now hand over the stage to my co-moderator, Fred Grant, Associate Principal at Simpson, Gumpertz and Hager, and a member of the Lifelines 2021 Conference Technical Committee. Fred, please take the stage.
Thanks, Greg. So on our panel today, we have Jeff Bachhuber, Director of Geosciences from Pacific Gas and Electric Company, Ken Hudnut, Seismic Expert from Southern California Edison, Maria Martinez, Director of Gas Engineering from SoCal Gas and San Diego Gas and Electric, Simon Zodu, Director of Regulatory Compliance and Specifications Division, Los Angeles Department of Water and Power, Rudy Mulia, Principal Engineer from Chevron, and Professor Davidson will also be joining the panel. Please recall that you can enter questions using the Q&A button at the bottom of your screen. Craig and I will take turns asking questions from the audience to the panel. I'll start with the first question. The question is, what has your organization done to improve lifeline resilience since 1971? And what are your current and ongoing efforts? What do you see as important future trends? Please allow for earthquake and other hazards. We will ask each of the panel members from the energy sector to respond with a 2-minute limit, starting with Jeff Bachhuber from PG&E. Jeff?
All right, thank you, Fred, and welcome everybody. Thank you for your interest in attending today. PG&E has a long history dealing with earthquakes, starting in 1906 with the San Francisco earthquake, which occurred only 1 year after PG&E consolidated gas and electric services into what the PG&E we know today. The 1971 San Fernando earthquake did not have direct impact on PG&E infrastructure. It was too far away, but did provide important lessons regarding power system performance and also the cascading influence on codes and standards. The most impactful earthquake event since the 1906 earthquake was the 1989 Loma Prieta earthquake, which had significant damage to PG&E infrastructure from Monterey north to the Marina District in San Francisco. This event provided the impetus for a major retrofit in seismic study within PG&E, ultimately amounting to over $2 billion in retrofit. Initially focused on substations addressing vulnerable equipment such as transformers and breakers, but then extending to over 90 buildings that were retrofit and extensive replacement of gas pipeline networks. It also spawned research and development. Some important activities in that space included electric equipment seismic qualification and improvement in standards, R&D activities such as shake table testing of components. PG&E has various seismic programs that are outlined on the slide here. Recent activities are associated with our integrated seismic risk management program. And this is a focus on developing a uniform platform that integrates all of our gas, electric, generation, and building portfolio. It allows us to run damage models or integrate damage models, look at system performance across all those different subparts of the PG&E system, and importantly, identify interdependencies. We have now integrated our entire gas and electric system, distribution and transmission, into a single seismic damage model using the SARA tool. We run scenario earthquakes, estimate damage locations. This helps us prioritize mitigations, also assess effects from different types of ground failure, including surface ground rupture, liquefaction, strong ground shaking. I believe any seismic program should include a healthy amount of interest and focus on research and development, especially collaboratively across utilities. This allows us to standardize our models, also to improve our fragility assessments of components that then we bring into the models, and leverage funding. That's really important to be able to get the best bang out of our buck. So with that, I'm going to turn it back to you, Fred, and look forward to questions later on in the program.
Great. Thanks, Jeff. Moving on to Ken Hudnut. Ken?
Hi, everybody. So yeah, it's my privileged to be representing Southern California Edison here today on the panel, and nice to be with all of you virtually. So what I'd like to talk about here is the sort of the long arc and the plan for reimagining the grid. And of course, Jeff and PG&E and our counterparts at SDG&E and LADWP are all in this together. It's a statewide effort. The white paper written by SCE is on the hashtag Pathway 2045, and there's a link at the bottom for those of you that might be interested in checking this out. But a little short pictogram on the side of the slide here shows you the 5 approaches that are being taken to achieve carbon neutrality by 2045. Decarbonize electricity, electrify transportation, electrify buildings, use low carbon fuels, and sink remaining carbon. And you see in the reimagined grid picture with the light blue background, this is something we're all striving to. You know, it's recognized that new investment is needed, and you're seeing that in the Infrastructure Week messaging from the White House. You know, Department of Energy is heavily engaged, as are many others. The interconnectedness that Professor Davidson pointed out and that Jeff also alluded to just now is critical, but so is the grid itself, how we do transmission and distribution, how we generate energy through the combinations shown here and other methods, and then you know, how this is all changing. And you know, there are so many good books out there and so many good sources of information. The recently released National Academy report that addresses energy sector resilience. So many fantastic references available on all of this. But in my short time here, I just wanted to say, this is the trajectory for the future that we're all a part of now. And resilience is, of course, all hazards, as was mentioned by Professor Davidson. This is the approach that we're taking, and also the systems approach that she mentioned. So we're considering not only our own systems approach, but also how we interconnect. And so now it's also our job to imagine how we're going to respond and then achieve restoration of service after a future impacting event, and not only to imagine those earthquakes that have happened historically, like Jeff mentioned, the 1906 earthquake and Loma Prieta earthquake in the Bay Area. Here in LA, of course, we had 33 Long Beach, as well as the 71 earthquake that we're commemorating here with this series of events. But also in the 50 years since, we've had the Northridge earthquake that struck in LA, and several more remote earthquakes in Southern California, 92 Landers, 2019 Ridgecrest, to name a couple. In Ridgecrest, PG&E had the gas service territory, but SCE had the electric service territory there. And in Northridge 94, that was more of a direct hit on LADWP infrastructure. And same with 71. So the toppled transformer shown by Professor Davidson was from 71, and that was the Sylmar converter station, recently completed at the south end of the Pacific Intertie, which is important to all of Southern California, but especially owner-operator LADWP. But so we can maybe come back to that during questions, and I think I've used my allocated time here. So thanks for having me on the panel.
Thanks, Ken. Same question now to Maria Martinez. Maria, take it away.
Hey, Fred. Thank you, and good afternoon. I'm very happy to be here today, joining this panel and talking about a very important subject today. And you know, I think a couple of the things that Jeff and Ken mentioned are pretty relatable. I think one of the biggest things of maintaining that lifeline resilience is making sure that the infrastructure that's here today is maintained, and we invest future to keep up the integrity of the system. And so for like SoCal Gas, we've been able to have a pipeline safety enhancement plan that's replaced certain vintage pipelines, tested it, and then a very extensive valve program that's helped minimize the distance between valves to minimize the impact areas should an earthquake occur or damage occur anywhere along the system. And in addition, we've also done a lot of participating in industry committees and collaboration with societies like ASCE, which are, very important organizations and pivotal to companies and really nationwide that help set those standards so that we're doing and designing the equipment that's going in today to be able to withstand natural forces. That could be anywhere from the way we designed the girth welds, the material going into making sure our pipelines are more ductile, knowing that we're here in California, and obviously a higher risk for earthquakes. So again, continued investment in R&D is pivotal. And then also, in the lifeline piece is, and Professor Davidson touched a little bit about it, but is the diversification of portfolio and energy that's available so that we're not solely dependent on electricity and have other resources for that. And with that, SoCalGas, does have the Aspire 2045 goals of being carbon neutral by 2045. And that means also investment in hydrogen and renewable natural gas that we're currently working on now. So that's it for me, Fred. So back to you.
Thank you, Maria. And moving on to our next panelist, Simon Zodu from LADWP. Simon.
Good afternoon, everyone. Thank you for this opportunity. It's always welcome for LADWP to participate in this type of engagements and share ideas. A little bit of background on the Los Angeles Department of Water and Power. We are the nation's largest municipal utility. Unlike a lot of utilities, we are vertically integrated. That means we own and operate our generation, transmission, and distribution assets. On the slide, you see a breakdown of some of the assets that we are continuously maintaining and making sure that we provide reliable and resilient service to the city of Los Angeles. We do have 4 million residents within the city, and we support all the businesses within the city. So we take reliability and resiliency very, very seriously. The Sylmar earthquake in 1971 was the turning point for Los Angeles Department of Water and Power. At least on the powering side, a good portion of our power infrastructure was sustained serious damage, including the Sylmar converter station and the Pacific DC intertie that brings renewable hydropower from the Columbia Gorge. So since then, we've been constantly upgrading our design standards, our construction standards by choosing materials that will be more resilient, as well as applying new seismic requirements to our substation and transmission work. So you can tell from the data on the slide that we are very capital intensive, and we make sure that resiliency is an important aspect of what we do. There are two criteria that we always have been applying for the last 50 years, and they are diversification and redundancy. We diversify our resources. Our resources include renewables, hydro, natural gas, coal, nuclear, energy storage, geothermal. We have a very diverse portfolio of resources, as well as geographically diverse in terms of we bring in resources from 5 different states throughout the Western United States. So we make sure that there's some level of redundant, diversification in case there are some changing conditions, and we'll be able to withstand and recover from rapidly from any type of disruptions. Second is redundancy. By design, we make sure that there will be a backup system for the majority of the systems we have. And as we always try to improve our service, there are 3 areas that we constantly look at as threats. Number one is the earthquake that we're always designing and planning for. Recently, wildfires have become a clear big issue. All those orange lines that you see on the map our transmission corridors coming to the city of Los Angeles. And we want to make sure that we have a good wildfire mitigation plan to make sure that the wildfires would not impact them. A new and emerging threats that we have right now is cybersecurity, and we're doing and putting a lot of investment in that area to make sure that that threat is mitigated. So I'll stop here, and we'll be very happy to answer questions as we go along. Thank you.
Excellent. Thank you, Simon. And finally, last but not least, same question to Rudy Mulia from Chevron. Rudy?
Thank you, Fred. I'm really delighted to be invited to be this panel discussion to represent Chevron. I'd like to share what we have done after the Loma Prieta earthquake and Northridge earthquake in Laos. I wasn't with Chevron back in '71, so but I can share with you what we have done. First, after the Loma Prieta earthquake, we did the seismic hazard mitigation project. That project, that earthquake is an eye opener for Chevron. We don't have much damage as a result of the earthquake, but given a longer duration, there might be something. So that's why at the time the company will proactively generate this project to basically to look at every structure in our facility in the West Coast and other high seismic zone. During that project, we basically developed the criteria our own, and it's in line with at the time where RMPP was being developed. We are in the same committee, so it was a tested criteria as based on what we have seen during the Loma Prieta, the ground shaking that we have, and how the performance of all the non-building structure that have been impacted. Even though there's no much damage, but we know based on the experience what's happening in the facility. So we did the extensive study at the time, about half a dozen of engineers over a year looking at every structure and the typical structure. That's including the petrochemical facility, marine terminal, marketing, as well as pipeline and building where our control building. All right. So the next also we also implement the CAL-ARP prevention program, which is previously called RMPP. And since we finished the project, this seismic hazard mitigation project, we continue implement this program to inspect all our facility. And also it's even though the CAL-ARP is only for California, we also implement the same criteria for others facility where there is no regulation to check our existing structures. So we use the same criteria as CAL-ARP. For example, in Utah, there is no CAL-ARP program available there. Another item that we did is a building specific inspection program. This is basically a roadmap that how we're going to inspect our building. I mean, the resiliency is not necessarily just planned, but a lot of our control house that operate our facility is very important. So this program is basically, we create a roadmap of a building, how to inspect a building, because we know each building after we study that and where is the weak link of every building that we have. So when there's a big earthquake, we can use the roadmap, inspect the building, where are the damage going to be? Because in a big earthquake, usually the non-structural built item is the one got damaged, and we can't see what the main structural component that has been damaged because it covers a lot of the architectural feature. So a lot of the building, but during the Loma Prieta earthquake, a lot of been rat tagged, but basically it's only non-building stuff, non-structural component that has been damaged. So that will improve the resumption, the business resumption of the building. And we did the same thing with the plant structure specific inspection program. As a result of our seismic hazard mitigation project at the beginning after Loma Prieta, we know how our plant structure will exhibit the behavior after the so we specifically know or look at where the critical point that we have to inspect. Lastly, not least, we also serve as an industrial committee to help develop best practice to design and assess our industrial facility, so we can share what is important in the seismic design and possibly for the changing in the code. For the future trend, we are living in a digital world nowadays. So the structural integrity management system is very important for us to make sure that our facility can perform reliably. Structural health monitoring system as well. We are looking into that, how to integrate it into our facility. And lastly, not least, the other digital technologies such as digital twin. So we're looking at that as well. With that, that's my end. Give back to you, Fred.
Very good. Thank you, Rudy. With that, we'll wrap up the first question, and I'll turn it over to Craig Davis to talk about the next question.
I have to unmute. So sorry about that. Thank you, Fred, and all of the panelists. This is great. And we're getting a lot of really good questions from the audience. So we're going to move into those and try to work our way back to some of Rachel's questions. So there's a few on a common theme, so I'm going to try to group them. There's the concept on resilience, right? So there's a general concept on what a few questions on relating to what do the panelists think resilience is in the energy sector. So I will summarize by just saying, what do you believe a resilient energy sector is? One of the questions came from just trying to get a quick definition without elaborating in great length, because we don't have a lot of time, from each of the panelists. So maybe if you could give a quick statement on what you think it is from each panelist in about 30 seconds or less, hopefully 15 seconds. So let's just start with Maria. I see Maria on the screen.
Yeah, thanks, Greg. So really for the energy resiliency, you know, I guess I love the topic of this workshop, right? And this committee, this overall theme is of Lifeline, because I think that really resonates with what's important when we talk about resiliency, and it's maintaining our critical infrastructure that's needed, like as Professor Davidson mentioned, like hospitals that we want to make sure stay online and provide a service. And then, you know, reducing the outage time overall to, you know, customers and industries so that they come back on and are able to provide a service, or that, you know, families can come home and feed their families and have warm water, and things like that. So, you know, I think it's really having a diverse energy portfolio that allows us to be able to adapt, keep, you know, critical services on, and when we can't, you know, be able to bring them back on as quickly as possible.
Thank you, Maria. Ken, do you have a brief statement on what you think resilience, energy sector resilience is?
Yeah, I think it's well shown by the graph that Professor Davidson used from Qatar. And we used a similar diagram in the USGS publication on the shakeout scenario, just showing that through time, whether it's a flat line or increasing GDP for the region, whichever version of that diagram you want to pick, you have an impacting event, and then you look at the time it takes to get things back to normal, either at the same baseline or even, you know, picked up from there. So we talked about in the USGS products associated with the shakeout scenario that an example of a relatively resilient response would be Northridge 94, whereas you showed in your work, Craig, within a matter of a couple or a few years, things were more or less getting back to normal in the valley. And then you take an example like Katrina, where there was probably insufficient investment in getting the region back. And so even when we had the AGU conference in New Orleans just a couple of years ago, there were still entire tall buildings that were dark at night because they had not yet been reoccupied. So Katrina was an example of a longer duration disruption and not getting the economy or the population back. And so we would see that as a less resilient example. So it's that ambition that we share, I think, that we don't want to have a non-resilient response from any of our major urban centers in California or the West Coast, or for that matter, nationwide or worldwide. We want to have a resilient response. And by that, we mean we get things back to normal. We restore things within a matter of a couple few years. And that's the hope. But of course, it takes a major investment to have that kind of a resilient response.
Okay, thank you. Jeff, do you have anything to add? If it's repeating, you could just say nothing to add, or if you have new things, feel
No,
free
sure.
to join in.
Resilient system is a flexible system, including both system hardening, so reducing the potential impact vulnerabilities of key parts of the system, and redundancy. I think it's important to look at interdependency. So that's both within an organization's infrastructure, but between organizations also. And once you identify those interdependencies, those are good focus points for adding redundancy or system hardening to make an overall more resilient system.
Great, thank you. Terrific additions. Rudy, do you have anything to add?
Yeah, this is in addition to Jeff. I'm agreeing with what you said. Interdependency, and see in the energy sector for like oil and gas and Chevron, it's not just reliability or integrity of our facility, but how we integrate it into the system, how the supply chains from one point to how we're going to get our product to the public in an efficient way during an emergency like a big earthquake. So it's not just oil and gas, but the entire industry has to support the system, infrastructure, how we're going to truck or do railroad or your trucking or even from the sea. That can be disrupted when there's a big event. So every sector has to have a piece in this to get a resiliency as successful.
Thank you. Great addition on the interdependencies. Simon, do you have anything to add?
Yes, I'll just add to what Maria mentioned earlier. Resilient energy sector is that one that's adaptable, both in the near term and long term, and a system that will survive any type of energy disruption without significantly impacting our customers.
Excellent. So Rachel, you started this, and I'd like to hear you. Well, go ahead.
I thought those were great answers.
Okay. Thank you. Thank you. So yeah, I do too. It was terrific with the broad spectrum of everybody. I think we've covered everybody's definition of resilience from what I read. So Fred, let me hand this back over to you now.
Thanks, Craig. I'm going to return back to one of Rachel's questions also that actually dovetails quite nicely with one of the questions from the audience. So Rachel's third question from her presentation was, what barriers are we likely to face, obviously, in the context of implementing, operationalizing resilience in the energy sector? What barriers are we likely to face, and how can we overcome them? So we got a question from the audience asking, how can we collaborate with our local utilities on understanding the interdependence of our lifelines? Will it take a regulatory impetus to push engagement, or can we lean into our local communities for greater understanding? Would love to hear your experience and perspectives. So I'll open that up to the panel if anyone would like to weigh in on that. How do we operationalize, how do we understand better interdependence of the lifelines?
If I may start, I'd like to address the first question. In terms of barriers to resiliency, on a daily basis, I work on regulatory compliance, and regulatory compliance primarily in the energy sector is about reliability. We do have reliability standards, so we have to adhere to, but it's a new phenomenon to talk about resiliency. And I think resiliency should be included in reliability standards to make sure that we really, really fortify our standards to include earthquake, wildfire, and cybersecurity related interruptions that make place. That's a very important part. Another area is state and federal agencies' involvement in this area. There's a lot of need for funding, research that will be needed. And emerging technologies actually will help us a lot in terms of improving resiliency of our system. Our grid is becoming decentralized, and there's a lot of new technologies that come up that need to be incentivized at the state and federal level to make sure that there's a quick adoption of those and deployment of those in the system. Another big area, that the last one that I would like to mention, is rates. As a municipal utility, for example, in Los Angeles, we do serve the public, and we're a municipal utility, and it's very hard for us to raise the electric rates on our customers. So that's one of the barriers that we have. We cannot make sometimes the necessary investment in our infrastructure or resiliency related issues because these things are capital intensive and they're very expensive. So I just would like to throw those as part of the discussion.
Great, thanks, Simon. Anyone have anything to add
hey,
to
Frank.
that?
This is Jeff.
Go ahead, Jeff.
Yeah, so adding on to some of your comments, Simon, I agree. It really is important to get the trickle down from initial government initiatives that are mandating different types of practice, improved recognition of resilience. So that comes down to the regulating agencies. We are constrained by the framework of regulation. We have to have our rates approved, our plans, and right now they're really focused on life safety. And that constrains moving to resiliency, which is quite a bit different type of an approach. And I think that needs to be initially implemented by legislation. And we have a couple of key things. So the new infrastructure bill is providing a lot of funding for just general infrastructure development projects. And there are components of research and development in there. And also California has the Assembly Bill 1329 that was just brought as an initial initiative for discussion in February, I believe. And that has components of resiliency. And so we'll see what effect that has, but I think that will help the situation a lot.
Excellent. Thanks, Jeff. With that, I think I'll turn it over to Craig for the next question.
Okay. Thank you, Fred, and the panel. Our next question is, how is climate change resiliency incorporated into overall system design for your organizations? Due to sake of time and moving on, I probably only take the first few volunteers, or if I have no volunteers, I'll specifically ask somebody, but who might try to take a response to this? Maybe if we can get one from electric and one from gas, that would be awesome.
Hey, Greg.
Yeah, I could.
Okay,
Go ahead,
Maria first.
Yeah. Yeah, for the climate change resiliency, I think Professor Davidson kind of highlighted the fact that we're seeing an ever warming environment, right? And, I think here in California, we've seen over the years the increase of wildfire, and then also the mudslides that come in those areas, right? Following those kind of events. And so I think, just the continual investment in how we design and never really staying stagnant on how we look at things, right? Because, overall, it looks like maybe it's a gradual change, but really, if we're really looking at investing in installing assets that are going to be here for the next 30, 40, 50 years, right? where do we need to look ahead so that we make sure that what we install is resilient to that, and is probably take more into account the fact that there's a higher probability that it may be in a high fire zone, even though it's not today, right? So I think it's considering all those natural forces, and taking them to where they're projecting out and incorporating that to designs today.
All right, great, thank you. So Ken next, but Rudy, I want to put you on standby. I'd like to hear from your sector as well, but Ken, please respond.
Yeah, the differentiation between chronic and sort of more catastrophic impacts is an important one. It seems like a lot of people are more able to relate to something that's an instant impact, like an earthquake or a severe weather event. These long-term stresses like sea level rise or gradual increasing temperatures, these are things that are a little harder for people to focus on or understand those impacts or respond in the short term to things that may be a chronic stress. So this is well explained and discussed in the framework from Resilient Cities for the global effort led by Rockefeller Foundation. And so working with you, Craig, and Marissa Aho when she was with City of LA and advising Mayor Garcetti, we use the shocks and stresses in the Resilient Los Angeles report as one example. So when we're talking about adjustment over the long term to those chronic stresses versus the shocks, it really can help to sometimes use for an example of a scenario to use a severe weather event and look at coastal flooding associated with, say, a severe weather event and a surge associated with it, or even using the tsunami example to help people to really get their mind around what that short-term impact would be in the coastal zone associated with an event like that. And then that can help to frame it for the long term for climate change. So I was saying about how we use scenarios to help anticipate something that has not happened historically. We need to think in the longer term about what events occurred in early prehistory or even before recorded history at all, and think about those larger events that are scientifically quite reasonable. We have a physical understanding of what could occur, but we need to be ready for those types of events, not only the ones that we've seen historically.
Thank you. Rudy, do you have anything to add from the fuel sector?
Yes, a little bit. I'm not the expert on this, but anyway, the climate change and resilience is very important to Chevron, and I've been following the news. I think we have been the center of discussion in the world about oil and gas, and there are quite a bit of things that has been shared to the public. I think if you Google it and there's a report that Chevron has published that what is our plan. Generally, yes, we have to reduce the carbon emission. That's the goal, and we follow the Paris Agreement as for our future. And there are many new technology that we introduced in the Chevron that we are part of the research as well, including the battery and whatnot, nuclear fusions and as well as how we refine our product to produce less carbon, and including the carbon sequestration in our facility. So we are aggressively investing in this area, so for the better climate. So, but at the same time, we still have our duty to produce energy for the public. The world still depends on oil and gas.
Thank you, Rudy. I'll hand it back over to Fred now. We have slightly under 5 minutes left to go.
Great, thanks. Next question is, what are some catalysts that enabled investment of resources into resilience planning? And the audience member notes that sometimes it can be challenging to convince decision makers to invest in resilience efforts. So what kinds of things have been helpful to support those decisions? Maybe we'll start with Ken. Do you have any insight into that, Ken?
Well, I'll just give a quick answer. I think when we see a major impactful event anywhere around the world, whether it's a big earthquake happening elsewhere or something else, maybe cascading events associated with a big earthquake. I think of the March 11th, 2011 Tohoku earthquake, the tsunami, and then the Fukushima incident. These are things that can spur action, can be like a catalyst. And then even commemoration of an event as we're doing here, when we think back to 50 years ago to the Sylmar San Fernando earthquake, and as Professor Davidson noted, the policy downstream effects, it has had a catalytic effect, I think. And so just even the commemoration of such an impactful event, those are the kinds of things that I think of as catalysts.
Great, thanks, Ken. And Rachel, you touched on this briefly on your presentation about some of the psychological effects. Would you like to add anything about what catalyzes this?
Oh, yeah, I think certainly in big events can be the catalyst, as Ken said. Sometimes a new technology, or I can't remember now who was saying it, but sometimes trying to piggyback on another activity. So if generation is becoming more distributed for another reason, it could also have an additional effect of improving resilience. So looking for those opportunities, I think, where resilience can be improved as sort of piggybacking on something else that's trying to get done that maybe has a shorter time horizon, is something else. And then I think history has shown also having a champion who takes up the cause and can push things through can be very instrumental. I'm curious, actually, I don't know how much people transfer from one event to another. So even just, this winter, what happened in Texas, of how much that makes people think about, oh, well, what could the same thing happen, due to a wildfire, due to an earthquake or something. I think there's some evidence that we can trigger activity by, even not the same kind of event, but a similar type of event.
Great. Thanks, Rachel. Craig, do we have time for one more question? Should I hand it off to you for a closing question?
I will ask one. I guess we're done. Okay. Maybe I'll wrap it up now. We have a lot of questions that remain, and we appreciate your interest in this, but we're going to need to close this up for sake of time. And we will address all of the remaining questions and have those available on our website. So here's our closing statement. This concludes our webinar for the energy sector panel discussion. We thank the UCLA Samueli School of Engineering for hosting this event, the speakers, the panel members, and the audience for participating. We will follow up individually with any submitted questions that were not addressed. Please stay tuned for more conference activities in 2021, and also plan to attend a conference at UCLA in February of 2022. So thank you again to all, and this concludes our panel session.
Thank you so much.